We are now ready in this lesson to define and understand the major terms of mass and balance, which are essential as we progress through the subject. To start, let us remind ourselves of the definition of centre of gravity from a previous lesson. The force of gravity will act on the total mass of an aeroplane in a vertically downward manner at a point called the centre of gravity. It can also be described as the point of balance. You learned previously that the initial centre of gravity will move forward or rearwards, depending on loading and operation of the aeroplane. There are constraints placed on the limits of travel laid down by the manufacturer, documented in the aeroplane flight manual. It was stressed that if the forward or aft limit was exceeded, it would seriously affect aeroplane performance. The centre of gravity will move in flight due to fuel usage, flap and undercarriage position, and movement of crew and passengers. The movement about the initial centre of gravity is calculated and must be contained within the fore and aft limits at all times. We are now ready to define datum, balance arm and moment, which are all important components of calculating the centre of gravity. We'll start with the datum, which is a fixed point along the longitudinal axis of the aeroplane, as illustrated. It is the position set by the manufacturer as the zero or reference point from which all measurements are taken in determining the centre of gravity position. The datum can be located anywhere on the longitudinal axis of the aeroplane. The balance arm is the distance from the datum to the point where the mass under consideration acts vertically downwards, as illustrated. When using the balance arm in calculations, it is vitally important to follow the convention that arms forward of the datum are negative, and all arms aft of the datum are positive. A moment is the turning effect of a mass around a point. In this scene, you will see that to calculate a moment, we simply multiply the balance arm by the mass. Using a balance arm of 10 meters and a mass of 8,000 kilograms, the moment becomes 80,000 kilogram meters. It is important to know that a moment forward of the datum is negative, and conversely positive if aft of the datum. You will see that the positive moment is 80,000 kilogram meters, and the negative moment is 1,600 kilogram meters. If there are multiple moments, we must sum them up to end up with the total moment. In this case, the total moment will be 78,400 kilogram meters positive. We will eventually be dealing with some very high numbers involving moments, though life has been made easier because the operator uses a loading index. This is simply done by dividing the moments by a constant, thus reducing the moment to one that is much easier to use. The example in this scene shows a table of items whose moments are divided by the constant of 1 million. From the first line of the table, you will see that the basic empty mass moment of 22,107,854 kilogram inches is divided by the constant of 1 million, resulting in an index of 22.